This is a demonstration to showcase the SoCKit board's capabilities. First, we have a SoCKit board placed over here that's connected to our monitor via a VGA cable. We're also connected to our computer via a USB blaster cable for configuration of the FPGA. So first, let's start out by powering on the board. And as we power on the board, a default configuration will be loaded, and we'll see an image of the SoCKit board on screen. But that's not the one we want, so let's load a new configuration onto our board. We'll do that by going and executing a script to download a new SOF file. And now that we know it's completed because our monitor isn't showing anything, and that's because the ARM hasn't booted yet with the appropriate file. So let's do that. We'll unplug our USB cable and plug it into the USB to UART communication port to enable communication between our computer and the ARM. And on the back of the board, you can also notice that we have an SD card plugged into the port. This SD card contains 2 video files, which we'll read and stream into the monitor later. Now that we have everything set up, I'll go ahead and load our terminal program and load the appropriate settings. In this case, we'll be using COM4 for communication. And now we have a blank window, which means that we have established a connection with our ARM. And I'll reboot the processor, and we'll see that we have our process showing in the terminal window. Now that we've finished booting, I'll log in as the root user, and I'll execute our file. Finally, on the monitor, you'll see that we have 2 video streams loading from our SD card now being shown on our monitor. Let's take a more in-depth look on what's going on behind the scenes. Here's how the ARM communicates with our FPGA. We first have an SD card, which includes our 2 video files. These are read in simultaneously through 2 threads via our Linux system, and then decoded from MPG. These are then sent through a RAW to RGB conversion process, and on the FPGA side, we have our TDR3 controller, which reads into RGB values and then sends them through a frame reader, each 640 by 480. The FPGA also generates a pure black background and a few logos, and then sends all of these signals through a mixer that's 1920 by 1080. This signal is then sent through our VGA encoder and then finally output onto our VGA display. As you can see from this block diagram, we have a seamless, integrated hardware-software co-development platform. For any support questions, please contact us at support@SoCKit.com. Thanks for watching this video.